Hi there. In this segment, we will show how to perform the indirect tensile cracking test at intermediate temperature. In the case for Virginia, it's going to be 25 degrees C or 77 degrees Fahrenheit. The IDT CT test or Ideal CT is one of the required balanced mix design tests for Virginia Department of Transportation. The test is usually performed on short-term age mix and then with a cracking tolerance index criterion of 70. Our specimen could be lab compacted specimen or taken from pavement, as known as cores. For lab compacted specimen, in the case of the design, usually the mixtures is conditioned for 4 hours at the design compaction temperature and then compacted. The specimen then are conditioned and then tested using the IDT CT. In the case of the field-produced mix or plant-produced mix, usually any cooling is minimized and then the specimen temperature is taken to compaction temperature immediately and then compacted. The specimen diameters are 150 millimeter with a thickness of 62 plus or minus 1 millimeter. The specimen's air void is 7 plus or minus 0.5%. The mixture could be conditioned either in a conditioning chamber or in a water bath, but they must remain dry prior to performing the test. In this segment, we will show how to run the IDT CT test or Ideal CT test using a servo-hydraulic machine. In this case, we want to make sure that we have a loading frame with a capacity of 25 kilonewton and able to apply a load with a loading rate of 50 plus or minus 2 millimeter per minute. So first, we want to open up the software. And then we want to make sure that we're choosing the right application to perform the Ideal CT test. Once the software is open, we'll make sure to fill in the information in terms of operator, organization, specimen ID, and any comments you may have regarding the specimen, the test, or the mixture. On the right side, we do have the test tab, and then in this one, we can specify the test temperature. In this case, it's going to be 25 degrees C. The contact load, so the test must start with a contact load of 0.1 kilonewton. The test rate, in this case, is going to be 50 millimeter per minute. And then the post-peak load, the test must end when the load reached down to 0.1 kilonewton. The second tab covers specimen properties, so we'll be putting the specimen specific gravity, and in this case, it's going to be the GMB or GMM. The air void of specimen, we would like to remind that the air void of specimen must be between 7 plus or minus 0.5%. Thickness of specimen. So usually the thickness and the diameter of the specimen are measured prior to conditioning, and then we must use the average values determined. You could see that in the other segment. For thickness, it's going to be 62 plus or minus 1 millimeter and diameter 150 millimeter. And then we do have the setup tab that will have parameters related to the system setup. Usually these are left as default. And then we're going to hit the next button. In this case, we're going to enter the file name and we make sure that we save the raw data of the tested specimen on the computer. Once all the properties are fed into the software, the servo-hydraulic is going to turn on. And then after that, we're going to hit next. In this case, the ramp will be installing to the initial position prior to mounting the specimen to the jig. Now it's time to insert and align the specimen. Usually at this stage, the specimen is taken out from the environmental chamber or from the leak-proof plastic bags and directly brought and loaded to the jig of the machine. So in this case, the specimen will be loaded, and we want to make sure that the specimen is centered. Once the specimen is centered, now we're ready to run the test. So we will hit next and then continue. Once the contact load of 0.1 kilonewton is applied, the software will ask us if we're ready to run the test. Then we're going to say yes. And then now the frame starts applying a load at a loading rate of 50 millimeter per minute as previously set up. And then the test ends once the load decreases down to 0.1 kilonewton. So we see that the specimen is broken into two halves, and now the test is done. So the software will give you the cracking tolerance index, which is the parameter used from the IDT CT test or ideal CT test. In this case, it turned out to be 23.2. The cracking tolerance index is usually calculated from a load displacement curve measured during the test. And it's going to be the product of the thickness times the area underneath the curve times the displacement at 75% post-peak load over the product of 62, which is the typical thickness of a specimen or normalized thickness of specimen, times M75, which is the slope at 75% of the peak load, post-peak load, times the diameter. The higher is the cracking tolerance index. This indicates that the mixture is more resistant to cracking. For Virginia Department of Transportation, when it comes to the balanced mix design, the criterion for the cracking tolerance index or CT index is a minimum of 70. A CT index measured lower than 70 indicates that the mixtures will be susceptible to cracking. A CT index measured higher than 70 will indicate that the mix is resistant to cracking. In this segment, we will show how to perform the indirect tensile cracking test, IDT-CT or ideal CT, using a screw drive machine. First, we want to make sure that our specimens are properly conditioned, and then we're going to take them out from the conditioning chamber or from the water bath, and then we're going to load them to the IDT frame. In this case, the frame has to be centered under the loading cell, and then we want to make sure that the LVDT is properly set to be able to measure or record the displacement during the test. We want to make sure that the specimen is centered. Once we feel comfortable and the specimen is centered, we're ready to run the test. So first, we want to make sure that we have a minimum contact load with the specimen. In this case, we're going to bring the motor down by bringing the loading cell up until we hit a minimum contact load between the frame and the jig. We want to make sure to tare the displacement and to tare the load, because we want our test to start from a 0 millimeter in terms of displacement and 0 kilonewton in terms of applied load. So on the upper left corner, we're going to hit the button to start a new test. So we're going to select the test that we'd like to perform. In this case, it's going to be ideal CT. And then it will ask us for specimen diameter. We will be using the average measured specimen diameter. And then it's going to ask us for specimen thickness. We will be using the average measured specimen thickness. Once these values are fed into the machine, we're going to hit the play button. And then we're going to label our test or our specimen. In this case, I'm going to use the label trial. Then once everything is done, I'm ready to run my test, and I'm going to click run. So now the frame going to apply a load at a loading rate of 50 millimeter plus or minus 2 millimeter per minute until total failure of specimen or until the end load reaches 0.1 kilonewton. So once the specimen is tested, the screen will give you the cracking tolerance index, in this case 8.62. If you're interested in learning more about the calculation of the cracking tolerance index, please refer to the segment previously recorded using a servo hydraulic machine.